Hi and welcome to Cherry Pie Math. Today we're going to be talking about how to use long division for decimals based on fractions. And in another video I talk about how decimals come out of fractions, but in that video I mostly use calculators. In this video I'm going to be focusing specifically on how to use long division to get decimals. So I'm not going to go over really their relationship. If you want to look more into that, here's the link to the video. Otherwise we're just going to get right into it. So just a quick refresher, fractions and division are related because fractions just represent division. That bar in the middle, so like A over B is the same as saying A divided by B. That's all it is. Fractions and division are the same thing. So we can use long division, the handwritten kind, to determine decimals from a given fraction. So this will help us see like the meaning between like the 10th place, 100th place, thousandth place, etc. Like if you have like, I don't know, 0.ABCD, this is the 10th place, this is the 100th place, because we keep on going. And we'll see these occur as we do long division. There are some different possible outcomes. So one is that it ends pretty fast. So like 0.5, for example. I'll just write that in my marker. 0.5 ends right away. Some of them will end far away, and I'm not going to give an example, but you could go on for hundreds and hundreds of different decimal points, but it will end. Some of them will repeat pretty quickly, like 0.333, etc. So like the bar on top of the 3. And some of them will repeat far away. So like we're going to look at one example was 1/7. That is going to repeat after like 7 or 8 different digits. I can't remember right off the top of my head right now. So those are some different possible outcomes. Because we're doing this by hand, you will usually see this one and this one. But every so often you'll see one that repeats kind of far away, but never longer than like 8 digits, because no one has that time. We would just use a calculator at that point. So the steps really are, we're going to put the numerator or the top inside. So we'll put the numerator in here. We'll put the denominator. I'll just put that out here, and then you're going to divide it. You're probably going to run out of spaces because you're going to have a remainder, and so then you just kind of put a decimal point here, and then you keep bringing down zeros after that. So then you'll have like A, B, C, etc. So let's do some examples, because these steps will make a lot more sense as we show examples. So we'll start with an easy one, 4/5. So like I said before, here's my nice little long division. I would put the numerator inside. I put the denominator outside. And obviously 5 does not go into 4. It goes in there 0 times. So I'm going to add a decimal point, and then I'm going to add my 0. 5 goes into 48 times. 5 times 40 is 40. So then I would do this. I end up with my remainder of 0. I'm all done, and here is my decimal. So what I ended up doing is I added another 10th place, and that allowed me to keep on dividing, but because it was after the decimal, I have to make sure my answer has a decimal in the same spot. And that's really all it is. You're just going to keep doing long division like you have before. You're just putting it over there. So let's do another example, 1 divided by 3. So again, we have the inside, we put the 1, we put the 3. 3 does not go into 1, so I'll put a 0 there, and I'll put my decimal point. 3 goes into 10 3 times, and that is 9. Let's do it 3 times 3, so then I do subtract, and I have a 1. Again, 3 doesn't go into 1, so I bring down a 0. And again, I have another 3. And I'm actually going to end up with the same pattern, because I'm just going to keep on adding zeros, and I'm going to keep on having 10 and then 3, etc. And so this is my answer. I have 3 repeating, so I would just say 0.3 repeating. So that was the other case. So in this one, we ended right away. In this one, we're repeating right away. These are both fairly easy, and both ones that you'll see throughout the rest of your math careers, and you'll even see this on the ACT probably. Let's do this one, 7 divided by 4. So I put the 7 in here, and I put the 4 out here. This one's a little bit different because it's an improper fraction. The top is larger than the bottom, but it follows the same thing. I think, okay, 4 goes into 7 one time. So then I have that. I put my 4 underneath it. I have 3. 4 no longer goes into 3. So then I would have to bring down and a 0 and start my decimal because I'm out of numbers. So 4 goes into 30 7 times. That's 28, remainder of 2. And then I do it again until I don't have any more remainder, or until I can see a clear pattern of repetition. And this goes into it 5 times. And now I'm done. So that would be, my answer is 1.75 right there. And you'll notice patterns, especially with denominators of 4, denominators of 5, as you keep practicing. But the cool thing about patterns is that honestly, you don't even need to know them, as long as you know the very basic way to do it. You put the top inside, you put the bottom outside, and then you divide them and keep on adding zeros after a decimal if you need to. So let's do that one more time with 1 divided by 7. So I'm going to put my 1 inside. I'm going to make that nice and long, put my 7 there. Okay, so 7 does not go into 1, so I start my decimals and I add another 0 inside. So 7 goes into 10 once. I have a 3, and again, 7 does not go into 3, so I'm going to bring down another 0. 7 goes into that 4 times. And a lot of this relies on just quick recollection of your times tables. So I would also recommend just reviewing your times tables if you're going to be doing these by hand. Then it goes into 20 twice. So then I have 14. That gives me 6. I'm going to bring that back down. 7 goes into 68 times. That's 56. And 4. So you can see I'm still going. This is taking me a lot longer than the other ones did. 7 goes into 45 times. So that's 35. And I have remainder of 5. And I bring down another 0. 50. And that is 7 times. And I have a remainder of 1. Hopefully this ends soon. Okay, and now I start again. Okay. Notice that this 10 is the same. And that means that now that they match, I'm going to end up with the same cycle over and over. And so it is going to repeat all of these things. Now that I see that this is the same as this remainder, then I'm going to start repeating. And that's an easy way to see if you're going to start repeating. Like here, I knew that this matched that, so it was going to repeat. But here, this never matched my initial 70 or my initial 7, and so I wasn't going to have to worry about it. This is one of those examples where you have to do it quite a lot of times in order to see that repetition. The only one I've really seen where you have to do it by hand is where the denominator is 7. Everything else is pretty fast. You're able to see if it ends or if it repeats. But it's good to see the process. You just keep on adding zeros and bringing them down. Just remember, you need to have a dot there to represent when you're starting the decimal, because I ran out of numbers here. So some things to remember: numerator on the inside, denominator on the outside. It will usually end or repeat pretty fast, so you don't have to worry about it unless the denominator is 7, but now you know. So if it's 7, you know to keep going until you see that repeating. And you just keep adding zeros. If you run out of digits to use, you just keep adding zeros upon zeros upon zeros. And like I said, you probably will be able to use a calculator for the rest of your life, but it's nice to know where they come from, and that skill of long division will help you later, especially in 11th grade when you're using letters to do this. So I hope that helps.